Hello, everyone. Good afternoon, good morning, or good night, wherever you are in the world. Thank you for joining in for today's RAVENNA webinar with the title Lockdown Rock, presented by Luca Giaroli from DirectOut. My name is Andreas Hildebrand. I bet most of you already know me. I'm working for ALC Networks out of Munich, and ALC Networks is the company behind RAVENNA, the IP media networking technology, which is open and fully standards-based. Our guest today will be Luca Giaroli from DirectOut. He's acting as product manager, and he has a very renowned reputation in the pro audio business. He has served for very big events in the past. And he's also the inventor and mastermind behind the GlobeCon control system. Luca is working out of Italy for DirectOut, which is a German company. DirectOut is specialized in developing essential pro audio connectivity, so everything MADI and audio over IP. That's the field where DirectOut has very nice and well built products on offer. Needless to say that they are all RAVENNA AS67 and 2110-30-31 compatible. So our agenda for today, most certainly we will hear from Luca about the Lockdown Rock project, which is an actual project which has been executed a short time ago. We will also see live examples during the webinar, and at the end we will have a Q&A session. Without further ado, we will jump into the topic, and as an introduction, we will have a quick video for you.
Possiamo avere una dichiarazione, diciamo, la loro sensazione da parte di ciascuno.
Bene, quindi com'è andata?
Beh, direi che è andata bene, come avere dei musicisti in studio praticamente.
Bellissimo, bellissimo, è una figata pazzesca, il feeling secondo me ottimo.
Per quello che riguarda l'esecuzione è stata fluida, non c'erano dei drop veri, solo qualche ticchettino, ma che rendeva comunque fluida l'esecuzione, quindi direi che la sensazione è assolutamente positiva.
Gli scrocchietti sono proprio leggeri, non danno fastidio.
È tutto suonabilissimo, per quanto ci siano pochissimi millisecondi di ritardo, probabilmente percettibile solo per chi lo suona e non per chi ascolta.
La situazione è risultata completamente fattibile.
Che dire, questa avventura è nata da una telefonata e si è trasformata in una figata. Quando durante il primo lockdown ci siamo sentiti con Giaroli e Scavazza sembrava tutto abbastanza fattibile. A complicarci la vita ci ha pensato internet. Non abbiamo mai mollato e ringrazio tutti i musicisti e anche quelli che non hanno partecipato a questo video. Poter utilizzare latenze basse per il monitoraggio incrociato e buffer più consistenti per i flussi di messa in onda è stato quello che ha garantito qualità e fattibilità. Grazie a tutti.
All right, that was the introductory video. We now hand it over to Luca Giaroli from DirectOut, who will run you through the presentation. So Luca, you should be able to take it from there.
Perfect, guys. So welcome everyone. As you could see in the video, we did it. So we had to struggle a little bit finding the right internet connections, but in the end we made it. Our goal was to let several musicians spread around the Italian territory play together with no clicks in real time, live, as if they were on the same stage. So during this webinar, we will go through all the details to let you understand how we did that and how you could do as well, just using a combination of nice devices and technologies. So thank you, Andreas. Thank you, the Ravenna official channel, to host this seminar. Let's go. Time is running fast, and I want to keep some time for your question and answer. So lockdown rock, the show must go when? Which were the conditions? Which were the situation? Which was the situation? Well, due to the COVID-19 pandemic, forced production method to change. And for many people, work from home, including artists, talents, hosting shows, etc. So we thought that the remote production need increased drastically, but video conference software uses heavy encoding and compression of audio and video. So we are not happy with the quality of Zoom or GoToWebinar or all the other things. We are happy about the fact that we can do it from home, but that is not the quality that we have in mind when we are talking about professional application. So, but almost everybody has a network connection at home. So we thought, how can we make use of that uncompressed audio over IP? So the scope is that whenever the standard internet connection is the only way to go, you have to deal with several, problems and several constraints. So, for example, there's no predictability in terms of latency, bandwidth, and packet loss. So you have to bear in mind that whenever you are using a standard internet connection, results will vary. No matter what are the number of precautions or tests or pre-check that you can do during the show, anything can happen once you don't have the full control of the means of transport, which is in this case the standard internet connection. But nevertheless, we tried, and the results that we could come up with is absolutely satisfactory and can be offered as a professional service. Having said that, of course, in the end, you are still using the standard internet connection. So what we used is the DirectOut proven JTNM tested Ravenna implementation. We used a bunch of Ravenna IO inside of Prodigy devices, PRODIGY.MPs. The advantages of using DirectOut devices offer many options to optimize the Ravenna transmissions. We will see a bunch of examples which are extremely interesting. Last but not least, the fact that we could use a PRODIGY.MP, which is a multifunction processor, having on board everything from the microphone amplifier all the way to the headphones amplifier, passing by local mixing possibilities, zero latency monitoring for cross monitoring and stuff like that, and having the possibility to control those devices entirely from a remote location has been of paramount importance. If you want to know more about what we understood and we learned from the several experiences we've done since the first lockdown, you can take a look at the white paper that DirectOut came up with, where we defined kind of quality levels A to D, depending on the different, aspects that you can count on, different features and different, settings that you can play with using from the dedicated internet connection or dedicated private connection, or the consumer and the official one, having or not having GPS based and other tricks that we can have a look later on. First of all, even if you are using a standard internet connection, if you want to have a Ravenna stream perfectly be transmitted from one place and received from one or more other places, you need to have a PTP Grandmaster. So if you go for the PTP Grandmaster with the GPS, you have several pros. So you have a phase accurate PTP sync in all locations. You don't have to transmit the PTP over the WAN. The minus or the cons is that you do require a GPS synchronized Grandmaster, so it's impacting the budget that you have to play with. Could you do it without? We can show later on that you could, but you just have to give up with some, quality / performances / latency in case you will not have the possibility to be linked to a GPS satellite. With the PTP Grandmaster without GPS, you have pros, which has one central Grandmaster is required, just one. And then no Grandmaster device at the artist place is necessary. So the plus is that you save some money, but the minus is that the PTP transmission over the WAN is required, is the only way to go and to get all the several places synchronized. And of course, you have an increased jitter, which might lead into a not accurate phase. And we'll also have another side effect, which will increase the amount of buffer that you have to keep just to compensate for this jitter, which is impacting on your arrival times of the several packets. What about the WAN connections? Link with the granted or guaranteed and symmetrical bandwidth, of course, is a pro. So if you can rely on guaranteed and asymmetrical bandwidth, you can reduce the latency, you can reduce the probability of packet loss, etc. The minus or the cons is that that is not valuable everywhere and is in any case require a little bit more budget than a standard and private home internet connection. If you have links without guaranteed and symmetrical bandwidth, you have positive aspects. Well, the most clear one is that more or less a standard internet connection is available everywhere in almost every private home. The cons is that you have unpredictable behavior in terms of latency. You have to struggle a little bit more with the packet loss, maybe, and etc. So it must be clear, I repeat you once again, that using public internet connection, there are no means to modify or configure the network. So you have to play with what is available in that particular moment, unless you have, paid and very expensive, granted and guaranteed. And even if you have those, you never know what can happen during the show. We decided to go for one of the methods that we could use to combine several RAV IO or Ravenna modules all over the places. And we decided to go for the most easy to go. And we had a partnership. We started a partnership with an Italian company, an IT company called VIVIVALDY. And we asked them, can you tune for us a VPN for our needs? So it's not just a standard VPN, but it's a VPN which is tuned in order to transmit real-time audio, uncompressed audio, PTP if needed, managing the multicast traffic, and last but not least, I would say first, is a plug-and-play solution. So VIVIVALDY is a zero config proven solution successfully tested with DirectOut devices. And this is exactly what we are using today for our live examples, what we used to record that video and to broadcast live that test. So you are receiving a pre-configured VPN router, and you don't even have to change your port forwarding in your domestic or house modem or something like that. As soon as that is connected to the internet and the power is plugged, anything is happening automatically, and all the pre-programmed routers are joining into a VPN, and then from any place where you have the router or any place you have a VPN software client, you can take the whole control of the entire thing. So there's no need to configure anything. And that's the reason why we wanted to offer that to everyone who could receive a rack with a pre-configured device and connecting the power, cable, microphones, and headphones, and the rest could have been done totally and completely from a remote position, anywhere in the world. What about packet drops? Of course, one option, and the best one, could be the usage of a stream redundancy based, for example, on ST2022-7. But, well, we should consider yourself lucky if you have one internet connection. So most of the time, thinking about the second one for redundancy is just, it's just a dream. So what VIVIVALDY grants is that the packet retransmission is, if required, is automatically done by the VPN routers. So this is absolutely true for the streams which they do have enough receiving buffer at the receiving position. So by the time that you are waiting for the packets to arrive, you store that temporarily in your internal memory, and then the longer is the buffer that you can take, the longer and the higher is the probability that if a packet should be retransmitted, it will arrive in time. Of course, that is not applicable to the low latency, or let's say virtual zero latency packets or streams that we are using for cross-monitoring purposes. In that case, there's no really any chance that a packet which has been lost by the IT infrastructure, by the internet provider, whatever, can be recovered. But that is not really a big issue, because artists more or less are used to have a little bit of drops when they are using in-ear monitors. So the net audio effect, if you are losing a few packets, is not that different from the radio interferences or little disconnection that you have during the normal operation with an in-ear monitor, as long as you can keep that loss limited. And if you remember the video, the artists were saying from time to time we could hear a little bit of glitch, but they were not real drops or something like that. That is because we wanted to keep the receiving buffer as low as possible to minimize the latency from one place to the other and let them play live. So jitter packet jitter, sorry. So the PTP, well, if you are sending the PTP over the internet infrastructure, of course, you might receive a very high jitter, or you can extract the PTP with very high jitter. The good thing of the implementation of DirectOut is that we have filters that can reduce the jitter on the receiver. And last but not least, when the media clock that you can extract from the incoming PTP is not stable enough, you do need a sample rate converter, which is part of the standard package of the PRODIGY.MP, and therefore you can let the RAVENNA sites be synchronized on top of the PTP that is transmitted. But then when you have to create your media clock, you can be independent and just apply an SRC, some sample rate converter, between the local media clock and the incoming RAVENNA streams. Streaming large input buffers, several hundred milliseconds, are required to accommodate the packet jitter. And this is exactly where I wanted to stress one fact, that not only the GPS-based PTP is strongly suggested to have the phase accuracy, but because also it gives you the possibility to lower the buffer. You don't need to keep large buffers to compensate for the packet jitter. So the more is precise the PTP, the less is the discrepancy that you can have between the timestamp that the package is bringing on with. And the jitter is so precise that you can keep the buffer as small as possible, especially for cross monitoring. This is not a problem at all for the signals which should be broadcasted, because at that point you always have the time to realign everything to the worst case scenario and align the mix with the video, which is usually much longer in terms of delay time when you receive the video together with the audio. So what is the real challenge is the cross monitoring feeds, and not for sure the broadcast ones, which can be accommodate with a higher buffer. So one other key fact that allowed us to have both feasibility and quality, as Carlo Barbero, the project manager for the lockdown project, reminded at the end of the video, is that thanks to the Ravenna implementation, you are free to decide the not only the packet time when you create the stream. Well, that is not really impacting that much. What is really impacting is the amount of buffer that you are getting at the receiving time. So we used low latency streams for monitor only, taking the risk to have from time to time a little bit of glitch or packet loss. What that was, a kind of compromise that artists needed to accept in order to have a very low latency stream, while we didn't have any compromise in terms of quality for the broadcast feeds, which were received with the maximum amount of buffer that the Ravenna implementation offered, which can be very, very high. That is not only preventing the fact that the package could arrive too late, but also allow the VIVIVALDY to retransmit the packet in case of loss during the transmission. If multicast traffic cannot be used and unicast is required for streaming and PTP distribution, that's another nice option that our Ravenna implementation is giving you. No matter if you are using a ES67 Ravenna or SIMT or whatever, we always have the possibility to decide if you want to go unicast or multicast. And especially when you have to struggle with the upload capabilities of your internet connection, you don't have that much bandwidth to play with. If you can really manage the multicast traffic, is much better, because then you have to upload to the, let's say, the central cloud, where you are putting all the streams available from every location, and then from there streaming out. The multicast traffic is a big advantage. So basically what we did, we used the VPN on cloud. We connected in every location a PRODIGY.MP and the RAV.io built in, fitted in one of the two network options, through the cloud, which was provided by VIVIVALDY, and we decided to have a geographical cloud placed in a central place among the several locations that we had to connect. And of course, in order to see which are the performances that you can expect, VIVIVALDY is offering you a tool that before even starting to do things, or putting devices on or sending devices over, you just have to decide which are the locations that you want to use for the transmission project or transmission test and whatever. And from there, you can ping several public IP addresses that VIVIVALDY will provide you to understand which is the ping time, and then you can immediately understand what kind of performance you can expect, what kind of service or lockdown service you can expect. If you really want to play live, as we did a few weeks ago when we did that video, you really need to have ping time from the location to the cloud and back, which are maximum 10, 12 milliseconds. Then you can hope that the entire path from the source to the destination, including the AD and DDA time, can be kept within 13, 15 milliseconds, which is acceptable, comfortable, let's say, to play with for real-time operation. Beyond that, if your jitter time is bigger than that, well, then I don't want to say that there's no chance to do the thing, but you have to change the strategy, and then probably you have to distribute kind of a synchronism or a click or something, and everybody's playing on that click, but it's not that live any longer. Well, it is played live. You'll always have the possibility to re-synchronize and realign all the streams from all over, but it's not like playing live. So in order to achieve what we achieved, you really need to test the ping times. And then if the ping time between the several locations and the center of the cloud that you decided to go, or VIVIVALDY would suggest you to go for, if you can check and pre-check that, and then if you have from all the locations where the artists are playing are within 10, 12 milliseconds, you have very, very good chance to make it happen. In the real test we did, this is the very first test we did, which was Piacenza, Milan, and Ravenna. We just had to change one of the location, and we moved the base player from Piacenza to Verona, where we had a better internet connection. And then, but the rest is accurate, and the distance are more or less the same ones. And we mixed everything from Rome. In Rome, we didn't have a very powerful internet connection. In other words, that was the only location where we didn't have the fiber. But that was not a big issue, because in Rome, we didn't have low latency streams involved. The most important connections were between Milan, Verona, and Ravenna, where the players are, because from there you need to have a very low latency streams connections for cross monitoring. Where you have the location where you are maybe recording or streaming or mixing everything, well, then you can count on much higher buffer time, and therefore even if you have a slower internet connection, that is not a real issue. It's not a problem at all. Talkback timing and stuff like that will never, will never create you a problem or an issue. Well, the real challenge is to keep all the musicians happy with a very low latency stream. So I will invite Claudio Beckerfoss to join us, and we move towards the live examples, playing with the several devices, and we can show you what we can play with today. Claudio, welcome.
Hi, everybody.
So here you are, a Globcon global view in front of you, where you can see several devices connected in real time. The MP is in Reggio Emilia, where I am, and the RAVENNA is the one inside of the other side. And I have also an MC here in Reggio Emilia with me. So those three devices, ID 1, 2, and 3, are in front of me in the same room where I'm speaking from. Then we have another 3 devices, which are in Hanover, where Claudio is, which is something like 1,200 kilometers from here, more or less. So we have an Xbox RAV, which is the new baby from DirectOut, a very compact Xbox format, MADI to Ravenna, Ravenna to MADI converter. Then we have another PRODIGY.MP, and then Ravenna IO, a RAV IO inside of the PRODIGY.MP at Claudio's place. Then we have another 3 sets, let's say MP plus RAV IO in Rome, in 3 different places in Rome. Why they are in Rome? Just because they are using for other lockdown projects at the moment. So we asked them, can you lend us the connection for 45 minutes during the webinar? And they say, yes, not a problem. So we have 3 different locations nearby Rome. Actually, I think that the second one is really in Rome, in city, in downtown, but all the others are close to Rome. Those 3 locations, they, maybe with the exception of the second one, they do not have FTTH fiber connection, so a kind of almost fiber connection. So the fiber is closed, but not really connected to the modem of the house. So we are in the position here to show a perfect, transmission, but we would never be able to repeat what we've done the other day in real time, because the ping time between the several locations is simply not, not fast enough, not low enough to do that. But that said, it doesn't mean that only that kind of operation is the goal of the solution. You can, as you will see and listen, despite the fact that GoToWebinar, unfortunately, is not the best way to transmit real-time audio, the real audio quality example, you had it during the video that you had at the beginning, because that is a video that we could preload on the cloud of the GoToWebinar service. The real-time audio that we might transmit now will never be, acceptable, because the GoToWebinar is shrinking down and compressing everything in order to fit the bandwidth with the video and stuff like that. But nevertheless, we will show you that it is possible to do things even if you don't have the super duper fast internet connection. So situation number 1 in Rome, situation number 2 in Rome, situation number 3 in Rome. The connection between the several locations is granted by a cloud service and VPN routers. So I have a VIVIVALDY connecting those 3 units. There's another VIVIVALDY at Claudio's place connecting this one, and then another 1, 2, and 3. So we have a total of 5 VIVIVALDYs connected to the same cloud. And the cloud center, start of the VPN, is in Milan at the moment. So if you take your terminal and you try to, from my location, if I ping, for example, the device in Rome, I can see that I'm having a kind of an average of 44, 70, 88 millisecond, which is okay, but you immediately understand which kind of connection and stream performance you can expect. You cannot do miracles. You have to stick with that. You have to live with that, right? So interestingly enough, since I'm going through Milan anyway, if I ping Claudio's place, which is 118, you can see that, well, although it's much, faster, much, how can I say?
Further away.
Further away, the ping time is not the difference, which means that never say never. The fact that you are geographically far or not really depends on the quality and the speed of the connection between the several locations. So it seems that the ADSL or DSL of Claudio is, quite fast and very well connected to Milan, since I'm having more or less the same ping time going towards, Hanover or going towards Rome. It really depends. So in other words, what I want to say is that you really need to pre-check and double check the ping times before you start doing something. And once you know which are the ping times available between the several locations, you can decide what kind of quality you can offer, what kind of services you can come up with. So first of all, who's the PTP master here? And how can we get to the same PTP in order to exchange real-time audio uncompressed through a RAVENNA stream? Well, we on purpose did a very different, approach in several locations. In the 3 devices in Rome, we are using a GPS-based Grandmaster, very inexpensive, made by a Raspberry Pi with a special chip and a marine antenna, because the budget was not that large, so we couldn't afford, a very top professional. But nevertheless, if you get to the advanced section of the RAVENNA and you see which is the amount of jitter that you are getting from that Raspberry Pi, although the Raspberry Pi Ethernet port is not, equipped with hardware timestamping, so it's just a software timestamping. Thanks to the fact that you can put a little bit of filtering up here, you can see that the jitter is round about 1.4, it's round about there, 1.4 microsecond. Don't get impressed by this, graphic, because it really depends which is the end of scale value here. So it's not looking that bad, especially if you see that the jitter is round about 1 microsecond. 1 microsecond of jitter is easily what you can get in a large Ethernet infrastructure. If you don't have a PTP aware switch, maybe it's even worse. But in any case, those numbers are enough to grant you phase accuracy between places, because those PTP are perfectly synchronized and synchronous. And also, if you have to create your media clock out of that PTP, the media clock will result synchronous. So this is not a problem at all. And this is the case of the 3 devices in Rome, where they have separate VIVIVALDY routers and separate PTP Grandmaster. As you can see, since the Raspberry Pi, which are acting like PTP Grandmaster at the moment, they are connected to the VIVIVALDY routers and they are set to, produce multicast stream. We had to differentiate the domain in order to have the several RAV.io connected to the local PTP Grandmaster and not to get mixed. So 6 is the domain of this device. 7 is the domain of the other device in Rome, and we have the advanced operation here. 8 is the other one, and you can see here this one is even lower than 1 microsecond. Never know. I mean, this can depend on different situation. We are going through the VIVIVALDY routers, which is bringing the PTP inside of the local network, and if needed, is also uploading as a multicast traffic towards the cloud. And that's important, because, for example, we wanted to show that in Reggio Emilia, if, let's say, I'm not having a PTP based on the GPS, how can I get connected to those other places? If I don't have the possibility to get the PTP from a GPS, well, then I would be in trouble, because I cannot play on a completely different PTP. So I decide to take a note about the domain which is produced in one of the GPS Grandmaster in Rome, and I can decide to subscribe that. So I go to the advanced, I say slave only, and I set the same amount, number for the domain, and you can see that I am slave of that device which is running in Rome. But even if I'm using a heavy amount of, filter compensation that the RAV.io is equipped with, I still have a very high jitter compared to the ones which are, provided by the local GPS. 30 microseconds of jitter, it's okay, I can live with that. What is really high is the offset, which is, required in order to keep track of that, jumping, and, that is what forces you to have a higher buffer. And in any case, this would be enough to create a lot of problem in case you would need to extract a media clock out of that jitter. Claudio, you are free to interrupt me when I'm saying stupid things and when I'm not accurate enough in terms of technical filters.
Yeah, maybe we should move on to show also a bit the streaming once.
Yes.
So
okay, so it's important because then you can live with that. The important thing is that you will never be able to create a media clock out of that, and therefore the PRODIGY.MP in the sync page, not a problem at all, because in the network number 2, which is the one connecting my RAVENNA, is going through a bidirectional fast sample rate converter, which is letting me to have a different clock, media clock, extracted from a local Dante device, which is the one that I'm using to connect my Dante virtual SIM card from my computer back and forth for the webinars and for streaming other things. And therefore, I can see I have a very stable media clock, and I'm not having any problem at all because the network of RAVENNA is running with its own clock based on the PTP Grandmaster produced in Rome, but I go through a fast sample rate converter to make everybody happy. Claudio is doing the same. Of course, he's equipped with a GPS based if needed, but we just wanted to show that even if you have to cover a long distance, which is the case of Hanover connected here, you still have the possibility to compensate with the jitter filters, and you are not forced to have a GPS whenever the budget doesn't fit or you don't have the physical possibility to grab ones. You still have the possibility to transmit that. Its multicast is managed by VIVIVALDY as anything else. So let's consider close the chapter regarding the PTP. Of course, it's a waste of time to tell you that if you can, it is much better and is recommended to have a GPS-based local PTP Grandmaster. In case you cannot have it, you have as a second option the possibility to transmit it over WAN. So let's now go to the analysis of the several MPs and how they could be used or they are used in case of a lockdown rock. Let's say in Rome, we have a drummer. So if we have a drummer, we need the microphone preamplifiers, which are getting the several channels, and therefore we are bringing them into input flex channels, and we have dedicated dynamics and EQ and blah, blah, blah. Unfortunately, we don't have a drummer now, which is playing in Rome, so we are just pushing all the way up the gains of the microphone preamplifier to have some noise, at least to have some movement there. And then here's the trick. I'm controlling the device in Rome like as if I was controlling the one that I have in front of me, which is this one. I mean, if I don't tell you that this one is in Reggio Emilia and the other one is in Rome, you don't see any difference. The meters are arriving. I can mute everything. I can turn it on. I can mute the stuff. I can change the EQ if I need. So for example, for a kick drum or something like that, I want to have a low pass filter, for example, like this or something like that. That is important because the bandwidth that I can play with from Rome, if I'm using a domestic internet connection, will never allow me to transmit separate channels. I don't have enough bandwidth to transmit 8 different channels just for the drums. Forget about it. How can we judge which is the amount of bandwidth? Now, let's go to the output, and then we are just streaming 2 channels, which is the drum stem. 2 channels, right? If you go to the statistic, and you can see that you are already using in the transmission port more or less 3 megabits per second. Just with 2 channels, if you have to add a talkback microphone, you easily arrive 4.5 megabits per second. Well, in Italy, the average standard domestic internet connection is, if you're lucky, having 15 megabits per second. But you cannot count on that 15 megabits per second all the time. So if you want to keep some margin, you have to reduce the amount of bandwidth that you are using. So long story short, forget about having the possibility to send all the channels. So the trick is, although you are far away, you are creating a stem of the stereo using one of the internal matrices of the DirectOut MP, PRODIGY.MP, and you create your stem locally, and then you are transmitting the result of the left and right channel. So you put your pans, and then you send towards the RAVENNA output drums left and right, not the single channels, but the mix down of the left and right. That doesn't mean that the sound engineer is not capable to change in real time the leveling, for example, between the snare and the top, or EQing the stuff, because you can control that from a remote location. And if you want to do a good thing, you just extract those channels, all the drums, and you put it in your desktop, and you create a layout where you say, okay, this is the drum I need, and then I'm receiving the stem here, so I'm just doing that, and then I create a layout, and this is my mix. When I have to create my mix, I can get everything in front of me. So now, is that really important if I'm moving up and down the floor tom or the overhead left and right in Rome or in Hanover or in Reggio Emilia? As long as I can do that, and I'm getting that drum stem left and right. Why I'm not receiving that? Well, probably because I have to go in Rome and say, okay, go send the drum stem. So I created the drum stem, is played out, is loaded into the cloud, and I'm getting to Reggio Emilia where I'm receiving everything and I decided to mix from, and I simply enable the received of the drum stem. I'm receiving that, it's green, it's okay. Therefore, now I'm expecting to receive my drum stem here. If I recall the stem and I recall the flex channel, the layout, I can see that now if I'm deciding to reduce all those channels in multi-selection or whatever, I still have the possibility to decide how the stem is done, right? How every channel sounds, even if I'm from a remote position. The same story, let's get rid of everything, is done when you have to provide a zero latency or minimum latency in-ear monitor feed to the drummer, which is in Rome. It's
one question: what stream delay do you use now for the stem, for receiving the stem?
Well, from Rome, for receiving the stem, I can play with that. At the moment, I'm easy because I'm using not the maximum amount. As you can see here, the minimum has been, this is due to the fact that the analysis was not accurate, and then we need to wait for sometimes. And probably the PTP is having a shifting now, and I should, usually it's not normal to have a minus here, so I have to investigate a little bit more. But you can see that the stem is received from Rome with a minimum and amount of maximum, and then I'm keeping 341 milliseconds of latency, just because I can do the same amount of a buffer from all the stems that I'm collecting from all over the places. This is not a problem at all. Would be way too much for the the zero monitoring thing, but it's not definitely. Let me see if I can get rid of this problem. It seems that you see that these filters got so I can quickly put that problem away, just resetting that filter, and it's going back there. And then you see why it is strongly suggested to have a GPS. You will never encounter this problem if you have that, and then you will see that that minus will go away. Okay, so the key point is that when you are creating the local mix, you are not impacting the listening or the in-ear monitor feeds. So the DirectOut PRODIGY.MP lets you feed either different flex channels that you could use for in-ear monitor or reuse the same ones. But when you are sending those channels towards the in-ear monitor drums mix, you are just getting the signal from a different peak-off point. So if you reveal the source of what you are sending towards the in-ear monitor drums mix, you are picking off the signal before the fader So if the front of house engineer is playing around with levels during the show, this is not impacting the level that you decided to send towards the in-ear monitor of the performer. So you can pick off the point at at the fourth plugin, and therefore when you are mixing the levels of the in-ear monitor of the drummer, if they say, okay, I want to have the hat -3 dB, please, or something like that, you can do that from the metrics, and this is completely independent from the levels that the front of house engineer is deciding for the mix.
Yeah.
So this is
Luca,
also very
we
good.
are running a little bit out of time, so probably we should
yes,
move on and show a bit of the transmission we have set up here.
All right. So, for example, I can get to my Ravenna IO and send towards Claudio my microphone. I can play it on. I can go to the Claudio's place and make sure that he's transmitting his microphone, and there you go. So I can subscribe Claudio's microphone from here, and I can get it from in my place. So Claudio, can you talk to your microphone? There you go.
I can, yes, and I can switch off.
Now I can send towards the broadcast transmission Claudio's microphone, which was not the case. So now you are listening, not just myself, but also Claudio's microphone. Test again, microphone.
So I switched off now my GoToWebinar microphone and just talk through this one here.
So you can see that now I'm mixing in Reggio Emilia a microphone coming from Hanover in real time with which is the amount of delay that I'm adding to that. I'm receiving that with 117 milliseconds, and you can see that the minimum and the maximum amount of offset was between 2,000 and 5,500. So I decided to go higher, not a problem, and Claudio is connected via a Ravenna stream between his own RAV.io and my RAV.io, and I'm mixing everything and streaming out from my streaming master towards my Mac for the GoToWebinar thing. I think that I can show you that my microphone can be received from Claudio as well. So we are crossing the thing. So I'm changing something which is happening in Hanover, right? So
which is quite scary for me.
Which is quite scary for you. I know that you're not sleeping that well any longer, but Luca's microphone can be activated from my place. Claudio is subscribing that in his place, and then if I'm controlling the MP of Claudio from the place where I am, and there you go, my microphone. And if Claudio needs to EQ different my microphone for any reason, for his recording, for live or whatever. So recap, because then there's the question and answer time. The key things has been low latency streams for cross monitoring, remote control of everything for more than one engineer. So for example, during the real example that we showed you through the video, Enrico Belli was the front of house engineer taking care about the audio things, EQing and mixing everything. I was taking care about all the streams and the PTP and blah, blah, blah. And we were in two different places. I was in Reggio Emilia, he was in Rome. So you really have you don't really have limitation in terms of people, if they are authorized, who can grab the control of the devices, and you can simultaneously work. Claudio is running his own GlockCon, and he can have the same scenario, or maybe less or more.
If you open up the MP from Hanover,
you
can see that I can at the same time move here.
Exactly. My hands are here, so Claudio is moving that.
it's really me.
Exactly. Okay, so I think that time, is running very fast. I think that you got the point. So VIVIVALDY combined with DirectOut and Ravenna streams, VPN cloud, low latency stream from cross monitoring, higher buffer streams for broadcast events and lines. Remote capabilities have been the mix, which could make this test be very successful. I will give the ball back to Andreas.
That's it for today. As said, any further question, just shoot an email to ravenna@alcnetworks.de or browse the Ravenna Network page for any further information. So I'd like to thank everyone who dialed in today. The recording will be available let's say 2 days from today, and the slides as well on the Ravenna network site. Thank you everyone for staying with us, and hope to see most of you next week again. Bye-bye.
Bye-bye.
Bye.
Bye, and thank you, Luca. Thank you, Claudia. Thank you, Roland, of course.
Bye.
Bye-bye.
Bye-bye.